Hey everyone, this is part two. I'm kind of just setting things up real quick here. I realized one thing that I forgot to mention was I forgot to mention here, let's see, I forgot to mention here that we have to figure out if this is discrete or continuous. So when we talk about discrete and continuous, what we mean is there an exact amount that we can actually have as discrete? Like, for instance, Zach details cars, he can detail 0, 1, 2, 3, 4, 5, or 6. Can he detail 5.5 cars? Some of you might say yes, but that's actually a job not fully done, so he's not going to be able to do that. So uh, that would mean that this is discrete, okay? Um, so this would be like, number of tickets, like we've done in class. You can only have, you know, a ticket. You can't have half of a ticket. That doesn't work. Another thing that might stick out to you is an actual person. Like if so many people, come to an event, then you'll make so much money. Well, you can't have half a person come to an event. Again, some of you may think that, but half of a body will not be able to enter. So a discrete amount would mean that you can only have an exact amount. There are only certain numbers. Now, a continuous amount, okay, now, so this example is discrete. A continuous amount would mean that the numbers can change. For instance, like your height. If you really wanted to, you could break your height down really, 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 really small and have a little fraction. You can be 5'5", 5'6", 5'6.5", and so on and so forth. Compared to just being, you don't have to be just 5 feet or just 6 feet. There's lots of numbers, all of those numbers in between there. Your weight is another example, right? You can be 130.479, and you can continue on that scale if it's a really nice, however far it's measuring. But if you can get those decimals, those rational numbers, then that means that it is continuous. So discrete, only certain numbers; continuous, all of the numbers. So let's look at number 10. The band is selling candy. It costs $10 per box. All right, I see $10 per box, so I'm just going to do 10 times B. $3 to ship the order, and $3, so plus 3, right? The cost of the order is a function of the boxes of candy sold. Well, here's our equation. So the cost, all right, C, equals $10 per box plus the $3 shipping. Now let's think about this. Is this discrete or continuous? Well, if it's continuous, that means I could order like 3/4 of a box, but they're not doing that. You order by the box. So I can only order 1 box or 2 boxes or 3 boxes. So this is discrete. Okay. Our domain, what's changing here? What's our input? This is the number of boxes, right? And then what's dependent on the number of boxes? The cost. Okay, and for this one, that's what we're looking at here, because it's a little funky if you don't order any boxes. You don't have to pay the $3 shipping and so on and so forth. But this is what I want you to understand here. Okay. Okay, I want us to look at number 11 real quick, because this is a great example of continuous. So a sink contains 9 ounces of water and drains at 3 ounces per minute. 3 ounces per minute. Drains, that's taking away, so we're subtracting there, and we start with 9. So if we have 9 ounces of water and we take out 3 ounces per minute, there it is, right? 3 minus 3m. Now this equation is going to be continuous, because we can actually find a point, say like at half a minute or a quarter of a minute. And when we subtract from 9, we're not just going to have, think about water going down a drain. It doesn't just go exactly 1 ounce, 2 ounces, 3 ounces. You can have fractions of that water go out. So you can actually have a continuous numbers here. So the domain What are we changing here? We're changing our minutes. So our domain is actually the minutes passed. And when we're talking about time, we can start with 0. That's our starting time. How long, what's the most amount of minutes we can have? Well, if we put in 3, we'll get 9. 9 minus 9 will be 0. We can't take away after that, so it's going to stop after 3 minutes. Now our range is how much water is in the sink. So think about this, alright? So how much water did we start out with? We started out with 9. And how much water are we going to end up with? Nothing. So make sure you want to do from least to greatest on your range. So there you go. That's all that is, okay? Continuous and discrete. Alright. Alright, let's go ahead and look at our domain and range here. Remember, domain are your x values from left to right. Alright, so we want to look where the graph starts on the x-axis. It's right here. Okay, that's at -1. And we can actually equal that number, so use a less than or equal to. And we're going to go up. The graph stops right here at this x value, and that's 2. So we can go all the way up to 2. So if you use brackets, interval notation, you have that. That means our graph goes from -1 to 2 on the x-axis. Now when we talk about the y, this goes from bottom to top. So we're going to start right here. And we're going to go up and up and up to the top right here. So where did it start here? -2 all the way up to +4. Our y's don't get any higher than that or any lower than that. So we go from -2, y, make sure you put that to +4, and then in interval notation. And that's all it is. You're just looking how far left and right does on the x-axis does it go, and how far bottom up and down does it go. Okay, again, I apologize for this thing right here, but let's look. Our domain, our x. Where does this graph start on the x-axis? Right here at -1. And if I keep going this way on my x, what's going to happen? This graph's going to keep going to the right, so I'm going to actually go to positive infinity. So we'll have -1 less than or equal to x, and then less than infinity. You cannot equal infinity, so that's why we have positive infinity. Interval notation, bracket, and then a parentheses for infinity, because parentheses is used when we can't equal numbers. Let's look at our y values, our range. Okay, so if I start here at -3, 1, 2, 3, alright, and I keep going, this is going to keep going up and up and up and up. So I won't be able to stop here. I'm actually going to go to positive infinity here too. So we have -3 less than or equal to y. Oh, not equal to, but just less than positive infinity. Alright, and then our interval notation. There we go. Now looking down here, you should be able to see it okay looking at our domain. Well, which way? This graph keeps going this way to the left, so it goes all the way to -infinity. And if I keep going to the right, my graph does not stop here just because of that point. Okay, this point does not tell me to stop. I keep going to the right, and I will actually, this tells me to keep going to positive infinity. There's a little arrow there. So this goes to positive infinity. So right here, our x's will look like this, positive infinity. And then we'll actually have parentheses for both of these. Okay? And then finally, our y values, well, this graph will never stop going down, so we're actually going to start at -infinity and go up, but then it stops right here, doesn't it? At +3. So our y values go from -infinity, can't equal that, and then up to 3, and we can equal 3. So we say -infinity to 3. Alright, and that's it.